Hello and welcome to Astronomy Daily, your go-to source for the latest developments in space and astronomy news. I'm Anna, and I'm thrilled to have you join me for today's journey through the cosmos. We've got a packed episode for you today, covering some of the most exciting recent stories from across the space sector. First up, we'll explore NASA's Punch mission, which has just captured its first images of the sun's outer atmosphere. These groundbreaking images are giving us new insights into how solar material flows through our solar system. Then, we'll dive into some concerning news about the International Space Station. NASA's safety panel has issued warnings about increasing risks to the aging outpost as it approaches its projected retirement date. We'll break down what these risks are and what they mean for the future of the ISS. Next, we'll travel to Mars, where the Curiosity rover may have just solved a long-standing mystery about missing carbonates on the red planet. This discovery could reshape our understanding of Mars's early atmospheric history. We'll also look at fascinating research suggesting we're entering a period of more intense solar activity. Scientists believe a hidden solar cycle is awakening, which could lead to more extreme space weather over the next several decades. Surprisingly, this might not be entirely bad news. Finally, we'll hear the remarkable story of how Chinese scientists rescued a pair of lunar satellites that were stranded in the wrong orbit. This complex rescue operation involved overcoming numerous challenges and executing a series of precise maneuvers to salvage the mission. So strap in for a cosmic journey through these fascinating developments that are expanding our understanding of the universe around us. In an exciting development for solar science, NASA's Punch mission has achieved a significant milestone by capturing its first images of the sun's outer atmosphere. Punch, which stands for Polarimeter to Unify the Corona and Heliosphere, successfully completed its spacecraft commissioning phase just this week, with the mission's instruments now beginning to reveal new details about how the solar atmosphere unfolds and streams through our solar system. On April 14th, the mission's narrow-field imager and one of its 3 wide-field imagers opened their instrument doors and captured what scientists call first light, the initial images marking the beginning of the mission's scientific observations. The remaining wide-field imagers followed suit 2 days later, opening their doors and starting to capture data as well. These early images are quite fascinating. The narrow-field imager has captured star fields with the sun near the center of the image, while the wide-field imagers have provided expansive views of the surrounding space. Scientists are now working to calibrate these observations to better reveal the subtle details of the sun's corona and the solar wind. What makes Punch truly revolutionary is its constellation approach. The mission consists of 4 small satellites working together, 1 equipped with the narrow-field imager and 3 carrying wide-field imagers. Once these satellites reach their targeted alignment, their images will be stitched together to create a comprehensive view of the journey of the sun's corona and solar wind all the way to Earth. The narrow-field imager functions as a coronagraph, blocking out the sun's bright light to better observe details in the corona. Meanwhile, the wide-field imagers focus on the faint outermost portion of the solar corona and the solar wind itself. This combination allows Punch to track solar material from its origin at the sun through interplanetary space. During the calibration process, scientists will be removing about 99% of the light from the corona, enabling them to track the faint threads of solar material as they flow outward through space. Similarly, they'll remove star fields and background light from the wide-field imager data to highlight the subtle flow of the solar wind toward Earth. Punch will provide something we've never had before: global, 3-dimensional observations of the inner solar system and the sun's outer atmosphere. The mission aims to answer fundamental questions about how the sun's mass and energy become the solar wind, that continuous stream of charged particles blowing outward from the sun in all directions. Perhaps most significantly, Punch will be the first mission to provide imagery of the solar wind and coronal mass ejections in polarized light. This capability will give scientists new information about solar activity, particularly about the formation and evolution of space weather events that can create storms of energetic particle radiation, potentially endangering spacecraft and astronauts. The mission is being led by Southwest Research Institute, which operates the 4 spacecraft from its facilities in Boulder, Colorado, with management from NASA's Explorers Program Office at Goddard Space Flight Center. As the commissioning phase continues, we can look forward to increasingly detailed views of our dynamic sun and its influence on the space environment around Earth. Next up today, some rather concerning news. NASA's Aerospace Safety Advisory Panel has issued a stark warning about the International Space Station, describing it as having entered the riskiest period of its existence. During a recent public meeting, panel member Rich Williams expressed serious concerns about increasing risks to the aging orbital laboratory as it approaches its planned retirement in 2030. One of the panel's highest concerns involves ongoing leaks in a vestibule of the Russian Zvezda module, known as PRK. For several years now, Russian and American experts have been investigating small cracks in this area with no resolution on their cause or how to best address them. Officials from NASA and Roscosmos are scheduled to meet in Moscow later this month to update efforts to mitigate risks from these cracks. In the meantime, ISS managers have implemented procedures such as limiting repressurization of the vestibule, which connects a docking port to the rest of the station. The panel has also highlighted concerns about deorbit plans for the ISS, particularly in case of an emergency before the arrival of the U.S. deorbit vehicle being built by SpaceX. According to Williams, if the station needs to be deorbited before this vehicle is delivered, the risk to the public from ISS breakup debris will increase by orders of magnitude. This is a sobering assessment of what could happen without proper deorbit capabilities. Adding to these worries are mounting issues with maintaining sufficient spare parts for life support systems and delays with cargo resupply vehicles. Sierra Space's Dream Chaser vehicle has been delayed until at least late summer, and Northrop Grumman had to scrap its planned NG-22 Cygnus mission to the ISS due to damage the spacecraft sustained during shipping. Perhaps most concerning, the panel has pointed to what it describes as a large ISS budget shortfall underlying all these issues. Williams stated that all of these risks are actually a derivative of this budget shortfall and collectively contribute to potential compromise of the low Earth orbit transition plan. Though NASA allocated nearly $1 billion to ISS operations and maintenance in its fiscal year 2024 operating plan, with an additional $1.63 billion for crew and cargo transportation, the panel warns that these resources may be insufficient. In its 2024 annual report, the panel expressed grave concerns that if the necessary funds for the deorbit vehicle and supporting launch infrastructure, estimated at over $1 billion, come solely from the existing ISS budget, this will unduly strain NASA's ability to safely perform normal and contingency ISS on-orbit operations. Williams emphasized that as programs near their final phases, there's a temptation to assume fewer resources will be needed. However, he stressed that for the ISS, it is critical to maintain adequate budget and resources until the vehicle is safely re-entered. The panel concluded by acknowledging the demonstrated operational excellence of the ISS program, while remaining deeply concerned about the increasing and cascading risk attending the program over the next several years. With the station set to remain operational until 2030, managing these growing risks while maintaining safety standards will be a significant challenge for NASA and its international partners. Let's head over to Mars now for an update. Scientists may have finally solved one of the most enduring mysteries about Mars, thanks to NASA's trusty Curiosity rover. For decades, researchers have been puzzled by the apparent lack of carbonate minerals on the Martian surface, which doesn't align with theories about the planet's early atmosphere. According to our understanding, Mars once had a much thicker carbon dioxide atmosphere that could have supported liquid water on its surface. If that were true, the interaction between this CO2-rich atmosphere and surface water should have created substantial carbonate deposits. Yet these expected carbonates have been largely absent in observations from orbit. That's where Curiosity comes in. The rover has been drilling deep beneath the Martian surface, going down 1.2 to 1.6 inches into the rock. These samples are then dropped into its chemical and mineralogy instrument known as CHEMIN, which uses X-ray diffraction to analyze the mineral composition of the rocks. Thomas Bristow, a research scientist at NASA Ames and co-author of the new study, explains the significance. Drilling through the layered Martian surface is like going through a history book. Just a few centimeters down gives us a good idea of the minerals that formed at or close to the surface around 3.5 billion years ago. What Chemin discovered was surprising. Carbonate minerals were indeed present in the subsurface rocks, but they were effectively masked by other minerals, particularly sulfates, making them difficult to detect using satellite-based near-infrared analysis. This could explain why orbital observations have failed to identify widespread carbonates despite theoretical predictions that they should exist. This finding has important implications for our understanding of Mars's atmospheric history. The discovery suggests that carbonate deposits may be more common than previously thought, but they're hidden beneath the surface or masked by other minerals. However, even with these newly discovered carbonates, scientists believe the amount would still be only a fraction of what would be needed to account for the thick ancient atmosphere that Mars is believed to have had. So where did the rest of Mars' carbon dioxide go? Some portion might be stored in other yet undiscovered deposits, but a significant amount was likely lost to space over billions of years, as Mars' protective magnetic field weakened and eventually disappeared. Future missions and analyses focusing on other sulfate-rich regions across Mars could confirm these findings and help fill in more pieces of the puzzle regarding how the red planet transformed from a potentially habitable world with a thick atmosphere and liquid water to the cold, dry planet we observe today. The Curiosity rover, part of NASA's Mars exploration program, continues its scientific mission after landing on Mars in 2012. Built by NASA's Jet Propulsion Laboratory and managed by Caltech in Pasadena, California, this resilient explorer keeps providing valuable insights about Mars's history and evolution, even after more than a decade of operation on the red planet's surface. Next on the agenda today, it's back to the sun. When we think about the sun's activity, we typically picture the familiar 11-year solar cycle, with its predictable peaks and valleys of sunspot activity, solar flares, and coronal mass ejections. But fascinating new research from the National Center for Atmospheric Research in Boulder, Colorado, suggests there's a much longer cycle at play, one that could dramatically impact our space weather over the coming decades. Scientists have been reviewing satellite data, measuring the density of energetic particles around Earth, primarily charged protons, from the sun trapped in Earth's magnetic field in regions known as the Van Allen radiation belts. What they've discovered is evidence of the Gleisberg cycle, a little-known phenomenon first identified by German astronomer Wolfgang Gleisberg back in 1958. This cycle operates over approximately 100 years, causing the intensity of individual solar cycles to ebb and flow in a predictable pattern. According to Calvin Adam, lead author of the new study, usually over 4 solar cycles, the intensity of solar activity will increase. Then it will reach its peak, and then it will go down over another 4 solar cycles. The satellite measurements suggest we've just hit the lowest point of this century-long cycle, meaning the next 4 solar cycles could bring significantly more intense solar activity than we've experienced in recent decades. This has important implications for our technology-dependent world. More active solar cycles mean the sun's magnetic field becomes more tangled, producing more sunspots and subsequent solar flares and coronal mass ejections. These events can wreak havoc on our satellites, power grids, and communication systems. However, there's an intriguing twist to this story. While more solar storms are expected, the overall density of high-energy protons surrounding Earth may actually decrease. This seemingly counterintuitive relationship occurs because increased solar activity heats and expands Earth's atmosphere. If you get more solar activity, you'll get more heat and more energy into our atmosphere, explains Adam. If our atmosphere is getting more heat and energy, it will expand. As the atmosphere expands, the protons will run into that expanded atmosphere and eventually drop out. This could be good news for satellites and astronauts in Earth orbit. With lower radiation levels in the space environment between solar storms, electronic systems on satellites may experience less long-term degradation. Astronauts on the International Space Station might also be exposed to lower cumulative radiation doses, potentially reducing health risks associated with extended stays in space. Unfortunately, this doesn't mean all is well. While the baseline radiation environment may improve, we'll likely see more frequent and potentially more devastating solar storms. These events can cause rapid atmospheric heating, increasing drag on satellites in low Earth orbit, and forcing them to use precious fuel to maintain their altitude. A powerful solar storm last May demonstrated this risk, causing what researchers called a mass migration of satellites as thousands of spacecraft lost altitude simultaneously. During such chaotic periods, the risk of orbital collisions increases dramatically as operators struggle to calculate and adjust orbits with their usual precision. The worry that we are going toward more solar activity is definitely there, notes Adam. We have built an enormous amount of technology, including satellites and power grids, since the last Gleisberg maximum. But it's not all bad. Our paper suggests that the baseline environment when space weather is quiet should, in fact, be somewhat safer. For our increasingly space-dependent civilization, this research provides both a warning and valuable preparation time. Understanding these long-term solar patterns allows satellite operators, power companies, and space agencies to develop more robust systems and contingency plans for the more active solar weather that may lie ahead. Finally today, in a remarkable display of space mission recovery, Chinese scientists have recently shared details of their extraordinary 4-month effort to rescue a pair of lunar satellites that were left stranded in the wrong orbit. The DRO-A and DRO-B spacecraft, weighing a combined 581 kilograms, launched from China's Xichang spaceport on March 13th last year. Their mission was to enter distant retrograde orbit around the Moon and connect with the previously launched DROL satellite in low Earth orbit, demonstrating inter-satellite communication capabilities and proving the usefulness of distant retrograde orbits. But the mission quickly encountered serious trouble when an anomaly with the Yuanjing 1S upper stage left the satellites in a highly elliptical Earth orbit instead of their planned trajectory toward the Moon. Making matters worse, the joined satellites were spinning at a dangerous rate of once every 1.8 seconds, threatening both their structural integrity and their ability to operate essential systems. The rescue team first had to tackle this rapid rotation. Using DROB's attitude control engines, they managed to eliminate the spin over a 20-minute period. But telemetry data then revealed another serious problem. Both satellites had sustained damage to their solar arrays, their crucial power source. Working against the clock, researchers from the Innovation Academy for Microsatellites and Technology and Engineering Center for Space Utilization formulated an intricate rescue plan within just 40 hours. The team faced numerous challenges, including the complex orbital dynamics involving Earth, Moon, and Sun gravitational forces, extremely limited fuel reserves, and a rapidly closing window of opportunity. The first critical engine burn occurred on March 18th, lasting an impressive 1,200 seconds, and successfully raising the satellite's apogee, their farthest point from Earth, from 134,000 to 240,000 kilometers. Over the next 4 months, the spacecraft executed 4 more orbital maneuvers, utilized gravity assists, and made additional trajectory corrections. After traveling an astonishing 8.5 million kilometers, the rescue operation concluded successfully on July 15th, when both satellites reached their predetermined lunar orbits. When the satellites finally separated on August 28th and imaged each other, the extent of the damage became clear. DRO-A's solar panels were bent nearly 90 degrees, while DRO-B's arrays resembled broken wings. Despite these challenges, the satellites achieved their primary mission objective by establishing K-band microwave inter-satellite communication links with the DROL satellite, creating a 3-satellite network spanning the Earth-Moon distance. Wang Wenbin, a researcher involved in the project, highlighted the significance of this achievement. For the first time internationally, we have achieved the ability to use satellites to track other satellites instead of relying on ground stations. In essence, the ground station has been converted into a satellite and placed in low orbit. This breakthrough paves the way for new technological advancements in future Earth-Moon space and deep space exploration. The DRO-A satellite carries additional scientific equipment, including an all-sky detector to monitor gamma-ray bursts. China plans to leverage these distant retrograde orbits for fundamental scientific research in fields including quantum mechanics and atomic physics, taking advantage of the long-term orbital stability these unique trajectories provide. This mission recovery represents one of the most challenging spacecraft rescue operations in recent years, demonstrating remarkable ingenuity and perseverance from the Chinese space program. Well, that brings us to the end of today's journey through the cosmos. What an incredible set of developments we've covered. From NASA's Punch mission capturing its first glimpses of the sun's outer atmosphere, to the concerning safety issues facing our aging International Space Station. We explored how curiosity may have finally solved the long-standing Mars carbonate mystery, learned about the awakening Gleisberg cycle that could change our space weather patterns for decades to come, and marveled at the ingenious rescue of Chinese lunar spacecraft against seemingly impossible odds. If you're hungry for more space and astronomy news, visit our website at astronomydaily.io, where our constantly updating newsfeed keeps you informed about the latest discoveries and developments across the cosmos. While you're there, you can also catch up on all our previous episodes. Don't forget to join our community on social media. You can find us as Astro Daily Pod on Facebook, X, YouTube Music, Tumblr, Instagram, and TikTok. Following us ensures you never miss an update about the wonders of space exploration. Until next time, keep looking up. The universe has endless stories to tell.